The next lesson in Unit 2 polynomials is the third rule of exponents. So we're still on exponents. So we'll call this rule number 3. And that's dividing by the same base. Dividing by the same base. So when you're dividing by the same base, the rule is keep the base, subtract the exponents. So keep the base, subtract the exponents. I'm going to go through about 9 problems, just to give you a little heads up. So the directions will say simplify. Number 1. We'll start off very basic. I've got x cubed divided by x. So the bases are the same. The base is x. I'm going to take that exponent and take the exponents and subtract. So I'm doing the numerator exponent minus denominator exponent. So the top minus the bottom. There is no exponent on this x, but remember, if there's no exponent there, it's really a 1. So I'm going to actually put 1 in a different color. Maybe it won't show up as a different color, but on mine it is. We're going to do 3 minus 1, keep the base, subtract the exponents, that's giving us x squared. Number 2. Let's take a look at when I've got 2 variables. So I have y to the 5th, z cubed divided by y squared, z squared. So y to the 5th, z cubed divided by y squared, z squared. So it's really, there are 2 variables here. So we're going to do this as 2 separate problems. I'm going to take a look at the y's. I'm going to subtract those exponents and then look at the z's and subtract those exponents. I'm going to keep that base. I'm going to do 5 minus 2, and then z to the 3 minus 2. 5 minus 2, 3 minus 2, that's giving us y to the 3rd power, and then z to the 1st. I don't need to put that 1. If there's no exponent there, you assume that it's a 1. So it's y cubed z. For number 3, let's put some coefficients there. I've got 27 a to the 8th b cubed divided by 9 a to the 5th b. So my coefficients are 27 and 9. The operation is really division. I'm dividing. They're not the same base. One's a 27, the other's a 9. So you're not going to subtract those numbers. You are actually going to divide them. That's what the operation is. The only time you subtract are the exponents if the bases are the same. So that should say divide. So 27 divided by 9 is giving us 3. I'm going to keep the base. I'm not going to write the subtraction piece anymore. I'm just going to subtract 8 minus 5. That's going to give us 3. 3 minus 1. That's going to give us 2. So I have 3a cubed b squared. And I know I'm done because I only have 1 of each base. Number 4. I'm going to put a little star next to this one. This is a special problem. I've got c to the fourth divided by c to the fourth. Now if I follow the rule, I subtract the exponents. So 4 minus 4, that's giving us c to the 0. I cannot leave an answer with an exponent of 0. So here's I don't know if you know when you have a 0 exponent. If you try to put anything in your calculator with an exponent of 0, it's going to give you a specific number, but suppose you didn't know that. Anything divided by itself. So if I rewrite this as c to the fourth is really c times c times c divided by c times c times c times c. This is going to cancel, this is going to cancel, this is going to cancel. It's all going to cancel. So when it cancels, it's not a blank. There are actually ones here. So this is really 1 divided by 1, which gives us 1. So our answer is 1. And really, anything divided by itself is 1. It doesn't matter if it's a number, if it's a variable, the product of a number and a variable. Anything raised to the 0 power is 1. That's the rule. Anything raised to the 0 power is 1. Knowing that, the remaining problems that we're going to be doing will probably have that in them. So let's take a look at number 5. So number 5, we have negative 21 x cubed y to the fourth divided by 7x y to the fourth z. I'm going to take those numbers that are out in front, that negative 21 and 7, and I'm actually going to divide that. It's very similar to number 3. We had that 27 and 9 out in front. Now I've got negative 21 and 7. I'm going to divide that. That's giving us negative 3. I'm going to take the x's and subtract 3 minus 1. That's giving us 2. And then I have these y to the fourths. They cancel out. I don't need to put 1 because I've got other things. I have the negative 3 and the x squared. If that negative 3 and x squared wasn't there, then I'd have to put a 1. But you just cross them out. Now I've got this z hanging out in the bottom. That means if the same variable isn't up top for you to subtract exponents, that means that variable has to stay where it is. It has to stay put. So since it's in the denominator, that's where that's going to stay. That means my answer is going to be a fraction. You can't just move variables to the top, to the numerator and denominator. If you cannot do anything with the exponents, they're going to stay as is. So it's in the bottom, that's where it's going to stay. So our answer is negative 3x squared over z. Number 6. There we go. Now I've got a to the 7th over a to the 10th. Just focus on that. If we follow the rule of subtracting exponents, when I do 7 minus 10, I'm going to get a negative exponent. 7 minus 10 is negative 3. You cannot have an answer with a negative exponent. So what we're going to do is, the way that I like to explain this is, you're looking for the larger exponent. The larger exponent for the a is in the bottom. It's in the denominator. It's a 10. So that means that's where that variable is going to stay. If the larger exponent's in the bottom, that's where it's going to stay, and I'm going to subtract bottom up. So this is going to be 10 minus 7. But here's the thing, you can't have a blank top. Right now I've got blank over a to the 10 minus 7. So if there's nothing up in the top, you have to put a 1. You can have a blank bottom, you can't have a blank top. So this is 1 over a cubed. 1 over a cubed. All right, number 7. I've got 4 a to the 5th b cubed c to the 4th divided by 16 a cubed b cubed c to the 8th. There we go. All right, let's take a look at those coefficients. I've got 4 over 16. I can't divide that out. I'm going to get a decimal. Your answer can't have decimals. But if you notice you can't divide it out, your next thought should be, can I reduce it? Well, 4 and 16, sure. 4 goes into 4 once. So I can make this a 1, and I can make this 16 a 4. So I'm already starting off with a fraction. I've got 1/4. All right, now let's take a look at the a's. I've got a to the 5th divided by a cubed. I'm going to subtract those exponents, 5 minus 3. Well, really, the first question you should be asking yourself is, where's the larger exponent? It's up top, so that's where that a is going to stay. 5 minus 3 is 2. Now let's take a look at the b cubes. They're both the same. This is a b cubed here at the bottom. I don't know if you guys can see that well, but it should be a 3. So I've got the same thing up in the top and the bottom. That means I'm just going to cross it out. I don't need to put a 1 because I've got other stuff there. Now let's take a look at the c's. The larger exponent for the c is in the bottom. That means that's where that c is going to stay. And I'm going to subtract from the bottom up. So 8 minus 4, that's giving us a 4. Now this is an okay answer. It's really not the most simplified way to write that. I don't need that 1 up in the top because there's already something there. If it was a blank top, then I'd be leaving the 1, but you don't really need it. So it's a squared over 4c to the 4th. Number 8. We have 3x to the 7th, y z to the 4th, divided by 7x to the 7th, y to the 6th, z. Let's take a look at those coefficients, those numbers out in front. I've got 3 and 7. My first thought is, can I divide it? Well, I can't do 3 divided by 7. My next thought is, can I reduce it? Well, there's no number that goes into 3 and 7 evenly. So it may just happen, you just keep it. For this one, we're just going to keep 3 over 7. Now let's go to the x's. I've got 7 x's in the top. That's 7 in the bottom. That means I'm just canceling them out. For the y's, the larger y is in the bottom, so I'm going to subtract bottom up. So I've got 6 minus 1. 6 minus 1, that's giving us y to the 5th. That y is going to stay in the bottom because that's the larger exponent. Let's subtract these exponents. 4 minus 1, the larger z's up top, that's where that z is going to stay. 4 minus 1, that gives us 3. So I have 3 z cubed over 7y to the 5th. Last problem, number 9. I have negative 4a to the 4th divided by negative 5a squared b cubed. Negative 4a to the 4th over negative 5a squared b cubed. All right, so let's start with those coefficients. I've got negative 4 and negative 5. Can I divide them? No. Can I reduce them? No. But the issue here is they're both negatives. You can't have an answer with 2 negatives. When there's 2 negatives, that means they both become positive. So I'm just going to rewrite that as a positive 4/5. Let's take a look at the a's. The larger a is up in the top. This is a 2 here. The larger a is up in the top. I'm going to do 4 minus 2. That's giving us 2, so that's a squared. And then for the b, I've got this b cubed. I don't have any b up top, so that means it's just going to stay there in the bottom. So it's 4a squared over 5b cubed. And that's the lesson on dividing bases with the same exponent.